Hey everyone, this video is on gastrointestinal disorders, and I want to start with GI diseases that are about the lining of the alimentary canal. So remember we talked before about the alimentary canal being that whole long canal of the digestive tract of your body, all the way from the esophagus all the way to the rectum, and that it had basically the same types of tissues throughout it. Well, something could go wrong with those tissues, and so I want to talk about some of those. And I guess I'll start with the esophagus and work my way out toward the rectum, I suppose. Though maybe this first one, I'll do both of them. Because the first one I want to talk about is esophageal varices. Do you remember what varices were? We talked about when we talked about the circulatory system and we talked about venous return. We said that if you've got a lot of pressure on the veins, and the veins can stretch out. And one of the problems with that is that the valves that allow the veins to return blood to the heart fail because the space between the valve leaves gets too large, and it therefore allows or doesn't cause the blood to move only in one direction. We talked about this causing varicose veins in the legs, more commonly in the legs because that's where the pressure is greatest on the blood to try to move its way back up, and it's being pushed back down with gravity, right? But this can also happen in the esophagus. And in this case, the portal veins, those are the veins that are carrying that nutrient-rich blood from the GI system and from the spleen to the liver, etc. Those can have a lot of pressure built up on them. And in particular, if the liver stops functioning properly so that you're getting a backup of fluid pressure in the portal vein system, then you're going to get a buildup of pressure in the esophageal veins. And it's going to have the same kind of an effect. So as esophageal varices, varices comes from the same root as varicose, right? These are a stretching of the veins very close to the surface in the esophagus that therefore cause a failure of valvular activity, valvular competence, and as a result they get stretched out very close to the surface, and they can start bleeding. So you can start getting bleeding in your lower esophagus, which can be very problematic in terms of either digestion of blood or the coughing up of blood, etc. But if they really break open, or if they break open in your stomach, which can also happen, you can have massive bleeding into your GI system, which is a life-threatening emergency and very problematic. And often physicians talk about this because it's very difficult to control. You can imagine if you've got excessive bleeding, massive bleeding in your lower esophagus, you can't just sort of take a bandage or a tourniquet and put it on the esophagus, right? How do you stop that? And there are ways, including something that's a little bit like a balloon that goes down there and inflates and puts pressure on them, but it's not easy, and it is absolutely life-threatening. Okay, if we keep going down the alimentary canal, we could then get to GERDs, which is gastroesophageal reflux disease. Heartburn, but chronic and severe heartburn. This is a digestive disorder that's caused by a failure, in this case, of that lower esophageal sphincter. Remember, the esophagus connects with the stomach, right? Well, where it connects, there's a sphincter that stops those very acidic stomach acids from moving their way back up into the esophagus. If that sphincter isn't working properly, if those smooth muscles are not closing tightly, then you get stomach acid moving back into the esophagus, which can create some pain and harm. And it's not just sort of like, problematic heartburn. This will do serious damage to your esophageal tissue, so it really needs to be dealt with. This is generally called GERDs. And GERDs can be very problematic. It can be everything from sort of like modest interruption in your everyday life to potentially, very damaging, because if that acid keeps destroying the lining of your esophagus, you're going to have some serious medical issues. So that's GERDs. If we then go into the stomach, we could identify peptic ulcers. Peptic is just another word for stomach, if you'd like. We call it peptic ulcers. They are ulcers in the stomach, and the word peptid just comes from peptin, which is the enzyme, the digestive enzyme. But basically, these are ulcerations in your stomach lining. In other words, significant damage to the tissue of your stomach is called a peptic ulcer. it can be very, very painful. And up until not that long ago, we thought it was basically related to stress. So in the 50s, 60s, 70s, 80s, and 90s, if you were diagnosed with a peptic ulcer, your doctor would say, look, you got to avoid stress, you got to take it easy, you got to relax, because this stress is creating stomach acids, and those stomach acids are burning up your stomach. This is ridiculous. Your stomach is inherently capable of dealing with the acids it produces. That's what the stomach does. Remember, there's that mucous membrane that creates that protective mucus layer, right? So the real question is not why you have stomach acid, because you should have stomach acid. The real question is, why is it actually allowing your tissue to be destroyed? And the answer wasn't stress and isn't stress. The answer is one of two generally. The most common form probably of peptic ulcers is non-steroidals. That is to say, taking a lot of aspirin or ibuprofen or something like that really does a number on your stomach lining and can have some serious effect. So by the way, if you have some chronic stomach issues, if you get pain around your stomach region and you're taking a lot of vitamin I, ibuprofen, or aspirin for some reason, then that may very well be the problem, because you're breaking up, you're doing damage to your stomach lining. The other one is really interesting, which is something we just realized not too long ago, which is H. pylori is a real problem. It is basically an infection, a bacterial infection of your gastrointestinal system with Helicobacter pylori, which we call H. pylori or H. py. This bacteria does significant damage to your stomach lining and causes stomach ulcers. So far, that sucks. What sucks worse is if this keeps going, it'll tear right through your stomach and actually create a hole in the side of the stomach. And then you've got what's inside the stomach leaching out of the stomach. And now you might remember, this is a really bad deal, because I remember talking about this with you before when we were talking about the peritoneal lining of the abdomen and how you can have peritonitis. And peritonitis, up until recently, was almost always fatal. What would happen is if your GI system, if your small intestine, large intestine, or stomach broke open into your abdominal cavity, it would create so much damage so quickly that we really couldn't stop it before it killed you. Now we've gotten much better at dealing with these emergencies. Surgery's gotten much better. Surgeons, physicians have become much more skilled. We've got better medication. So your chances of death are not as high as they used to be, but it's still extremely life-threatening. So it's not the case that a stomach ulcer is just a little thing, it's not a big deal. If it tears through the wall of the stomach, it will create a significant infective agent in your peritoneum, causing peritonitis, inflammation of your peritoneal cavity, which is extremely problematic. Another possibility is celiac disease. And I bring this one up because we've talked about autoimmune diseases, and this is an interesting one. This is basically a hypersensitivity to gluten. And that's super problematic because gluten is in everything. What I mean is gluten is the thing that is in wheat and other grains as well. Barley, rye have gluten in them. And so everything from a Wawa sandwich to pizza to spaghetti sauces to pasta have wheat as a thickener, as a key agent or whatever. And what happens is when somebody who has celiac disease eats this, the presence of the gluten triggers an autoimmune response that attacks the lining of the small intestine. Here's an image of what happens. Remember we talked about the villi and how the villi of the intestines dramatically increase the surface area and allow for the absorption of nutrients to take place? Well, in this case, those villi become devastated by this autoimmune effect. And so you can see there in the image that what are long finger-like projections end up being little nubs. And those little nubs don't create nearly as much surface area and aren't nearly as effective. And the result of that is that people that have celiac disease that's undiagnosed or untreated, and therefore they're eating gluten and maybe they have gastrointestinal issues, typically they have diarrhea, cramping, things along those lines, are also doing a terrible damage to their intestinal lining and reducing their capacity to absorb proper nutrients. So they are also typically can be very malnutrition. So this is a real problem. The solution, relatively easy, which is don't eat gluten. But in Western society, that's really tough because gluten is in all kinds of things. So you have to significantly change your diet. Worse than that is Crohn's disease or colitis. These diseases are characterized by the inflammation and ulcerations of the colon lining. So basically, your large intestines have these significant physical damage, ulcerations. It can lead to diarrhea, uncontrolled bowel movements, rectal bleeding, severe abdominal pain. Crohn's disease is a little bit different than colitis. Colitis is limited just to the colon, so colitis is just your large intestine. Now remember, this is bad, but you can live without a large intestine. And in this case, if somebody has colitis and it's significant to doing damage, the solution might be to remove the large intestine and instead have a pouch outside the body called a colostomy. And that colostomy pouch allows basically for the collection of waste. Not ideal. I think you can imagine that's not a real great option. Here, by the way, is an image of what colitis looks like. And you can see in your GI system, that's some pretty significant damage there with the scope. And I'm going to see if, I haven't looked at this yet, but I think I could probably find a pouch or a picture of a colostomy pouch. So if I can, it's up here. There it is right there. And you can see that on the outside of the body is not an ideal situation either, but you can live with that. Crohn's disease is much more significant because it can happen anywhere. And so Crohn's disease can also happen in the small intestines. And if it works its way up the small intestines, as you know, this is where absorption of nutrients really is critical. So now you could have potentially all kinds of problems because you're not absorbing effective nutrients. We talked about pernicious anemia, I think, when we talked about blood issues. This can cause pernicious anemia because if you destroy part or all of your colon and part or all of your small intestine, now you may not be able to absorb key nutrients, let's say B12, and as a result of that, you can't produce adequate red blood cells. So you can see that this is really bad. And here you can't just do surgery. You can do surgery and remove the colon, but you can't do surgery and remove the small intestine because you're not going to be able to absorb adequate nutrients then. So very bad news. Then if we go further down the alimentary canal, we get to the possibility of diverticulitis, which is an inflammation, you know that because it ends with itis, of the diverticula. Diverticula are sort of stretched pouches in your lower colon. And they could just be there because of a genetic predisposition. They could be there because maybe you have something like colitis, and so you've had a lot of problematic bowel movements that caused a lot of stretching and a lot of trauma. But basically, these are open pouches. Now, a lot of people have these little open pouches in their lower intestines. So far, not that big of a deal. The place where it becomes a big deal is if they become impacted with waste, and then that becomes inflamed, and now you got diverticulitis. That can be really problematic and really problematic. So diverticulitis, if it's uncomplicated, if it's simple diverticulitis, there's medications that can be used to deal with this, so it heals relatively easily. But it becomes complicated when the inflammation begins a secondary problem. For example, if you've got acute inflammation, that could lead to a diverticular rupture. So now you've got a tearing, basically, of the lining of your colon, which creates significant problems. Or you could have sort of chronic inflammation that leads to scarring, and that's going to be some problems as well. And here's an image that gives you some sense of the diverticula and what they might look like and the kind of tissue damage that does. You can see, not a pretty picture. Basically, most of the stuff we're talking about here with the GI system, not really a pretty picture. I mean, no disease is really nice. The diseases of the GI system are probably the ones that are a little bit more icky, right? Colorectal cancer. Here's an image of a colorectal cancer that's growing. And remember, What is a cancer? A cancer is the rapid reproduction of dysfunctional cells. That's it. The cancer itself isn't going to kill you. What's going to kill you is that the cancer is going to move into other areas, displace functional cells, and cause physical damage or dysfunction that's going to stop necessary organs from functioning and therefore kill you. And colorectal cancer is a pretty common form of cancer. What we do to try to avoid this, and the reason I'm bringing it up is because I want you to be aware of this a little bit, even though it's probably later in life for you. But once you get over the age of 50, we basically recommend that everybody get a colonoscopy. And the colonoscopy is meant to send a scope and look for polyps. And the reason for that is the polyps are the first sign of colorectal cancer. So this is actually something we can do something about. So we don't do the scope just to see how things are going and then we know how things are going. Rather, that scoping also allows the physician the opportunity to remove those polyps and therefore remove possible starting points for colorectal cancer. This is why you see the commercials on TV for colonoscopy and whatever, and how you need to get checked out, and alternatives to that, which in my view are probably less adequate, that might check for blood in the stool or other kinds of indications in your stool of colorectal cancer conditions. Okay, so there's some having to do with the lining of the GI system. The other possibility is a disruption in the digestive system, so digestive disorders. We could start with a simple one, which is just lactose intolerance. Basically, this is somebody who has a deficiency in an enzyme called lactase, and as a result of that, can't adequately digest or break apart into its component parts. That's what we mean by digestion, lactose. So when they eat dairy that has lactose in it, it instead goes to their colon, and their colon has bacteria in it. As you know, the colon is filled with a microbiome of bacteria, and those bacteria eat up all that undigested lactose, and when they do, they produce gas. That's what bacteria often do when they eat stuff up. They convert it to gas, and they produce gas. And that gas means that you have gas as well. So bloating, diarrhea, abdominal cramping can happen because of the rapid production of gas in your lower intestines as a result of eating dairy. This is to some degree cultural as well, because if you don't eat dairy for a while, then you will lose the ability to produce these enzymes, this lactase. So there are cultures where they don't eat dairy regularly, and therefore they have much more common lactose intolerance, whereas in American culture, people tend to eat cheese and milks and other things well into adulthood, and as a result of that, lactose intolerance is somewhat less common. Another possibility, which is kind of interesting, because I like bringing up the weird stuff, is a microbiome dysbiosis. Okay, take a step back here and remember, what's the microbiome? The microbiome is the hundreds of different bacteria that exist in your colon, right? This is a supportive kind of environment, right? In other words, they aren't doing you any harm, you're not doing them any harm, and they are living there and actually keeping you healthy. It's a symbiotic relationship, good for both of you, symbiosis. Okay. What happens? Well, if for some reason that biome gets thrown out of whack, then problematic bacteria can move into that vacant niche. And this can create all kinds of abdominal discomforts and other kinds of issues as well. So physicians have now tried to kind of focus more on that microbiome and maintaining proper balance. And this is why you see this stuff on probiotics, and maybe, I don't know, maybe you've seen like a TikTok videos on taking probiotics, etc. It ain't that easy, because if you take a pill that has probiotics in it, it's got to get through your stomach, and your stomach is a vat of hydrochloric acid. So how much of that is really going to get all the way to your colon? The reality is not much. So it's not as easy as just taking a pill. One solution that's being used now to deal with C. difficile infection, which is a type of bacterial infection in your colon, is a fecal microbiotic transplant. Fecal microbiotic transplant. Yeah, that means we're going to take poop from somebody else, or at least a sample of the bacteria from somebody's poop, and place it into your colon to implant and promote and support a healthier microbiome. And it's showing that it's actually working. And so there's now physicians that really believe that there's a lot of other dysbiotic conditions that could be dealt with by basically taking bacteria from fecal matter from a donor and placing it in the colon of a recipient to grow a better microbiome. A little weird, but it turns out it's working. Right now it's being used for one particular problem, one particular bacteria, but folks are looking at this for other kinds of bacteria. Okay. Another interesting possibility, man, this video is getting on the weird side, everything is weird, is a toxic megacolon. Why am I pointing this out? Because I want to show you this. This is an x-ray of somebody with a toxic megacolon. And if you haven't looked at a lot of x-rays, then you're not going to be wowed by this. But I looked at this and I was like, holy shit, look at that thing. Okay, do you see that big sort of orb that goes across the chest from the upper right to the lower left, kind of like crossing the heart? You can see that, what looks like a big bubble. That is the large intestine. That is the colon. And that is massive. So massive that it's pushing its way up and out. This person must have had just a significant abdominal distension to make room for a colon that must be like that big around and just huge and pushing up. How does this happen? Well, this is called toxic megacolon, and it's where the colon, the large intestine, becomes dangerously dilated and inflamed because of an infection. And this can be a life-threatening situation. I mean, you can imagine if this thing burst, it's going to make a mess. And again, this is C. difficile, C. diff infection, a particular bacteria that's pretty aggressive in the abdominal cavity and can be a life-threatening kind of issue. So that's toxic megacolon. Really something you don't want. Pancreatitis is another possibility that's kind of related, I guess, a little bit. Pancreatitis is inflammation of the pancreas, and you should have guessed that. Itis, inflammation, pancreatitis. Okay. How does the pancreas get inflamed? Well, a lot of different reasons, and this is basically just pancreatitis is in general inflammation of the pancreas. But one that's interesting is if the outflow from the pancreas gets blocked. And the reason that's interesting, let's say, for example, we have, I don't know, some kind of blockage, an inflammation or stones or something that stops the release of pancreatic juices from the pancreas. Those pancreatic juices, you'll remember, contain enzymes. And what is the goal of those enzymes? To digest things like fats, carbohydrates, and proteins. What is your pancreas made of? Proteins. So you've got these juices in your pancreas that are designed to digest the pancreas itself effectively. Why does this not normally happen? Because normally the pancreas produces inactive forms of these enzymes, and they don't become active until they escape the pancreas and get into the GI system. But if you've got, say, for example, gallstones that's blocking flow of digestive fluids, or if you've got maybe the result of significant alcohol abuse, then those juices build up in the pancreas. And when they do build up in the pancreas, they will begin to digest the pancreas itself, causing significant inflammation, pancreatitis. One form of pancreatitis, I should say. Related to that is also exocrine pancreatic insufficiency, sometimes called EPI, which just basically means that the pancreas isn't producing enough enzymes. So you're getting malabsorption of nutrients because the pancreas isn't producing the enzymes you need in order to digest those things. And again, you might stop here and think, okay, so what does that mean? That means I've got like some kind of GI discomfort, etc. No, it means you're not absorbing the things that you need to survive. That can be a real life-threatening or health-threatening condition. So exocrine pancreatic insufficiency, EPI, really significant. Pancreatitis can be very significant as an inflammation of the pancreas, but if it's being caused by the pancreatic juices themselves activating in the pancreas rather than remaining in their deactivated state because flow through the rest of the GI system is blocked, then it's going to be really significant and create some potential damage and has to be managed aggressively. Okay, I think that's it with this video, and then we'll pick it up with the next video where we're going to talk about some liver issues as well. So I will see you in that video.